LCD controller. LCD is used to display some characters on the display, and we'll study how we can write different characters to LCD. So now let's assume we want to solve a problem. So if you look at the LCD, so this LCD is interfaced with the microcontroller. So this is the block diagram of our system. So now this is the block diagram of our system. Can you see the block diagram on the right hand side?
Yes, sir.
This is the block diagram of an LCD. And now we have to write a code for an LCD controller. This LCD has different pins. So this is the interface. So if you look at this point, so this is the interface between LCD and microcontroller. How many pins are used? How many pins are used in this scenario? LCD and microcontroller. How many pins are used in this scenario? So if you look at here, so 8, 9, 10, 11 pins are used. How many pins are used?
11.
11 pins are used. So the pins that is used at the LCD level is E. E stand for, what does E stand for? E stand for. E stand for enable, yes. E stand for enable. There is another pin that is called as R/W. R/W. Can you see this R/W?
Yes, sir.
Sir.
This is like some kind of a control pin. This is a control pin. And then you have another pin that is RS. RS pin. RS pin. Can you see? And then there are some 8 data bits. So there are 8 data bits. Okay, so this RS pin is connected to which pin of the microcontroller? Can you see? RS pin. Can you see this? RS. So which pin of the microcontroller?
2.
P1.2. So RS pin is
P1.2.
connected P1.2. So this RS pin is connected with P1.2. And what about RW pin?
Sir, P1.1.
P1.1. And now we are connecting the 8 data bits of the LCD to the microcontroller with P2.0. So this is P2. We have connected all this pin with P2. So with P2, so it means that these, if you look at P2, how many data bits P2 have? So P2 has data bits ranging from P2.7 to P2.0. P2.7 to P2.0. This implies that the pin DB7 is connected to P2.7. Similarly, what about DB1? DB1 is connected to which pin of the microcontroller? P2.1. So this way we can send different signals. We can send different signal to the LCD controller, and it can be programmed. So the pins that we can control on the microcontroller side is P1.0, P1.1, P1.2, P2. So now we have to write an assembly language program. We have to write an assembly language program, and we have to perform three simple tasks. The first task is to initialize the LCD into a 5.10 dot display with a 2-row and 8-bit mode. Okay, so there are different codes for the LCD. There are different codes for the LCD. So if you look at here, so there is a signal I/T. I/T. Can you see on the left screen? Can you see? So what does I/D stand for? Any clue?
सर कर्सर को मूव करता है
Yes.
राइट या
So
लेफ्ट
okay, so we can move the cursor to the left or to the right. So now if we see an LCD, so in LCD, so let's assume you can display different characters. So let's assume the LCD can have different characters. So now there is a cursor. So let's assume there are different characters that you can display here on the LCD. So now let's assume your current cursor position is here. If you want to move to the right, if you want to move to this location, what should be the value of I/D? If you want to move to the right position, so the I/D value should be 0. So when I/D is 0, the cursor will move to the right position. If we want to move on the left position, what should be the value of I/D?
One.
बताएं बेटा? 1. Then S. When S is equal to 1, what does it implies? S is equal to 1. Let's assume S is equal to 1. It implies that with display shift, whenever you write some character, it will shift its position. Okay, so if you see here, RL stand up, RL is equal to 1, you shift to the right. When RL is equal to 0, you shift to the left. Okay, so what's the difference between RL and I/D? जी बताए. In I/D, you only move the cursor position. You are not writing any data. But when you are using the RL signal, so RL signal, when you move, when you write any character, you send some data to the character, it will directly automatically move to the shift to the right. Okay, so now there are two modes of the design. When DL is equal to 1, so it means that you are sending an 8-bit data, and when DL is equal to 0, it means that you are sending a 4-bit data. Okay, so what's the difference between a 4-bit data or 8-bit data? Now if you look at this block diagram, are we sending an 8-bit data or 4-bit data to the LCD? What is the data size here?
8-bit.
8-bit.
8 bits. So in this case, you can configure the LCD into different modes. One is an 8-bit mode and other is a 4-bit mode. Okay. Now, you can also change the resolution of the LCD by configuring into two different modes. One is a 2-row mode and other is a 1-row mode. Can you see from the end? So if it's a 2-row mode, so what does it implies? It means that now in LCD you have 2 rows. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So it means it is row 1, and now it is row 2. So this is a 2-row mode or a single row mode? आवाज नहीं आ रही बेटा?
सर 2 rows
It's a 2-row mode. And if it's a 2-row mode, what should be the value of n? What should be the value of n? The value of n is 1. So the value of n is 1 because it's a 2-row mode. It means that now we can display. How many characters can we now display in this mode? how many characters can we display? So the number of character displays on row 1 is 1, 2, 3, 4, 5, 6. 6 characters are displayed in row 1 in this particular example, and 6 characters. So the total of characters that we can display is 6 multiplied by 2. So we can display now 12 characters in this particular example. We can also configure the LCD in a single row mode. So in a single row mode, so it can display larger characters. So actually the character will look like this. So maybe the character will look like this. So this is larger character. 1, 2, 3, 4, 5. So how many characters can be displayed now in this mode?
6.
6 characters. So 6 characters can be displayed, and if it's 6 character is can be displayed, so it's a single row mode. Single row mode. So what should be the value of n in this particular example? N should be 1 or 0.
Sir, 0 single row.
0.
Or single row. So it means that there are. Okay, now we have another mode of an LCD, which is the 5 cross 10 dots and 5 cross 7 dots. 5 cross 10 dots. So let's assume we have 5. Seven dots. Okay, for this configuration, for 5 cross 10 dots, what will be the value of f? F is equal to 1, and for 5 cross 7 dot, the value of f will be 0. Okay, what's a 5 cross 10 dot display, G? Can you kindly elaborate? Can anybody elaborate? This implies
एक सेगमेंट जो होता है अंदर जिस पे कैरेक्टर डिस्प्ले
yes,
होता है उसका मैट्रिक्स है, मतलब उस पे इतने ड्रॉ पिक्सेल्स
yes,
रिप्लेस
it's a pixel. So this represents a 5 cross 10. It means that it represents, so this represents the pixel in horizontal and vertical direction. So this implies, so can we, if we can write it like this, so this implies now we have some pixels. Okay, so it means that there are 5 pixels in this direction, 5 pixels. So this is 1 pixel, 2, 3, 4, 5 pixel, 5 cross 10, and 10 in this 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now there are all pixels. So this is actually the resolution. This is the resolution of one segment. You're right. So this is the resolution of one segment. So these are some pixels. So each pixel value can be either on or off at some particular instant. So now let's assume this is the 5 cross 10. So if you look at this, so let's assume this is 5 cross 10 dot display of a segment. So if we want to display A, so what will happen? So it means that this will be on, 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 and then some. Am I right or not? So these pixels will be on. The pixels in this direction will be on, so it will display an A. And this is all inside, like program inside the LCD, and you can send different characters to LCD and display them on the screen. So now we have a problem. So now we have a problem. We want to write an assembly language program. We want to write an assembly language program that perform this task. Number one. Okay. So we want to write an assembly language program. We want to initialize the LCD into 5.10.display with 2-row and 8-bit mode. And then we need to clear the display and write ABD54 on LCD. So this is our small program and we want to write. And actually, if you see that if we want to perform this task, if you want to initialize the display LCD into an 8-bit mode, what should be the value? So the value of DL is 1. For 5x10 dot display, the value of F should be 1. And if you want to initialize into 2-row mode, the n-bit value should be 1. Okay. So if we want to initialize the display and we want to send some command to display, want to send some command to the LCD controller. So first we have to send a pulse. We have to send some data to the LCD controller and then we have to send a pulse on E. So set a pulse on E. Okay. So what should be this pulse? This pulse should look like this. So this E is initially 0 and then we write a pulse. So when you send this pulse to the LCD controller, the pulse LCD controller, it will be configured into the desired mode and then it will receive the data. It will get the data that you are sending it on the, it will understand the data that you will send on the pins. Okay. So now if we want to write it something like this. So if you see this, Control V. Okay. So now we are writing an assembly language program from here to the assembly language program. Okay. So we can use this eq directory, eq. So it means that now we are saying eq E is connected to which pin? P1.0, am I right? RW is connected to which? RW P1.1. What about P? What about RS? RS is connected to
V1.2.
P1.2. And then we have this signals DB7, DB7. So DB7 equal DP7. Okay. So now we can have DB6 is connected with P2.6. 5 is connected to P2.5. 4 is connected to 0.4. PB3 is connected to 3. PB2 is connected to 0.2. 1 is connected with P1 and DB0 is connected to P. So what's our first task? Initialize the display. We want to initialize the display. Okay, if you look at this code, if you look at this initialize display, so actually what should we do now? What should we do now? Which mode should we use? Which
Say
mode is this mode? Can you see? Can you see the blue line? So whenever
yes.
So it means that we should now set the interface data length. We can set the interface data length. We can set the interface data length, the number of display line, and the character font. We can set this. So which mode will you use? We will use this mode. So if you see, so we set. So now I can copy the whole data. So it means that we can set this mode. So it means what should be the value of RS in this particular example? 0. What should be the value of? So now I can copy this data. Maybe I can copy this. So I think so. Copy नहीं हुआ क्या हुआ है? नहीं हुआ. Okay, maybe I can copy from here. Control C. Okay, so actually, if we want to set the interface length or something like this, so which data should we send? So actually, we can use this configuration. So how we can do it like this? G. What should be the code? So it means we can write a code like this: clear RS, clear RS, RS should be clear, clear RW, clear RW, clear DB7, clear DB7. Then what about DB6? Clear DB6, clear DB6. And okay, what should be the value of DB5? DB5 value should be 1. So set DB5, set DB5, set DB5. And what should be the value of DL now? The DL value should be 1. Why DL value should be 1? Because we want to initialize the LCD into an 8-bit mode. So set DB4, DB4, and then set DB4, then set DB3, set DB3, set DB3, and set DB2, set DB2. Why DB2 should be set? Why this DB4 should be set? Because DB4, if you look at DB4, so DB4 is connected DL, and the value of DL should be now 1. So DL should be now 1. DL should be now 1 here. What about set DB3 or DBC is N, and in this scenario N should be now 1. What about DB2? N should be 1. F should be 1. And in this case F should be. And in this particular scenario, we can ignore DB1 and DB0. We can ignore DB1 and DB0. Okay, this is one way. How many? Okay, how many? If you look at here, how many instructions have we written? जी बेटा, how many instructions have we written? जी आवाज आ रही है आप लोगों को? अब्दुल्ला,
Sir,
आप लोग जवाब नहीं दे रहे ना? How many instructions have we written here?
8 instruction. 8.
No. In this green.
6.
6. So we have 6. We have written 6 instructions. Instead of writing this 6 instruction, we can write a single instruction. So this 6 instruction can be replaced with a single instruction. Can we write it like this? move, move. Okay. Which port is connected to DB? Which port is connected to DB7 to DB0? Which port?
P2.
P2. So now in this scenario, P2 is our destination. So P2 is our destination. What should be now source? Which addressing mode should we use now? Immediate addressing mode. Okay. And which for immediate addressing mode there is a hash. Okay. Okay. Should we represent the data in binary or should we represent the data in decimal? जी बताए बेटा. Or hexadecimal. आवाज नहीं आ रही आप लोगों की.
Binary.
सर बाइनरी में
Binary. So it means this hash represent immediate. What about ampersand?
सब बाइनरी रिप्रेजेंटेशन होता है.
It's a binary representation. And which data we need to send? We need to send. Okay, so on DB send it should be clear. So clear, so 0. DB6 is clear 0. What about set? 1, 1, 1, 1. Okay, if you look at this, so in this configuration, when you want to set the interface data length and the number of display line and character lines, DB1 and DB0 is don't care. Either we can send a 0 or 1 here. So it means this is don't care. So you cannot write don't care here, but you can say, okay, 0, 0. Because it is don't care, so you can write here 0 or 1. So it doesn't matter. You can write 0, 0 here because these two are don't care. So these are don't care. Don't care. Either you can write 0, 0 or 0, 1 or 1, 0 or either you can write a 1, 1. Doesn't matter. It doesn't matter because I don't care. So if you look at this data, so this is now the first character is now DB7. The first bit is now DB7. Okay. The second bit is now DB6. Okay, so in this case, DB7 and DB6 is 0, 0. If you look at from this, DB7 and DB7 is 0, 0. So these are DB7, 0, 0. This is 1. This should already be 1. Okay. Now the following bit represent DL. And after following bit, it represent N and so forth, so on. बेटा आप समझ आ रही है या नहीं आ रही समझ? ठीक है? Now we have to send appropriate data. We have to send an appropriate data, but now we should send this data. We should send a command. How we can send command to LCD? कौन सी command हमें भेजनी चाहिए? Command कौन सी होनी चाहिए? What should be the command? The command should be enable LCD. Am I right or not? How LCD can be enabled? How LCD can be enabled? How LCD can be enabled?
सर कोई पल्स देंगे तो उसे मतलब
Yes. Pulse on which pin?
सर ई.
E. Very good. How we can give the pulse?
सर ऑन करवा लाइक मतलब उसको
First 1 and then 0.
Because we want to give a pulse. Okay, can we write? Very good, very good. So clear E. Set E. Am I right or not?
राइट सर.
And then clear E. And now because it is a subroutine, so we would like to enable LCD many times. So basically it is a subroutine. So we have written a subroutine. So this is now a subroutine. It's a subroutine. So actually it will return. So actually we can write here call Now we are calling this subroutine enable. Whenever you write it, it will act like a function. So it will, the control will be transferred here and it will create a pulse. So in this call enable LCD, what will enable LCD do? It will create a pulse like this, an E. Initially E is 0, then E is set to 1, and then is again 0. So a pulse is now created, called enable LCD. So when this pulse is given to the LCD, so now this pulse is given. And it will accept the data. When the pulse is given, now this data will be latched inside the LCD controller. And now the appropriate commands have been given to the LCD. Okay, and in this case, the LCD will be initialized. The LCD will be initialized. So actually, if you look at here, so it means that this is a command. These are the commands that we have sent to initialize the LCD. So now these are the commands that we have sent to LCD. So these are the commands used to initialize LCD. ठीक है बेटा? Okay, question? Okay. Now what's our another objective? We have to clear the display. जी बेटा बताएं.
सर हमारा क्विज है अभी.
बेटा जो टाइम है वो कब तक है? I have to finish this. I have to finish it very quickly. ठीक है? So now.
Okay, sir.
Okay, we have to clear the display. So if we have to clear a display, so now in this case, we have to clear the display. So we have to send this command, clear the display. So this is a clear display. So now we can write like this, clear display. Clear display, it's a label. Okay, now we want to clear the display. Which should be the value of RS? Clear RS. Clear RS. Then which command should we send? Clear RW. Clear RW. And then which value should we move to P 2.0? Move hash ampersand binary 000000001. Can you see it? So 00001. And now we should again call enabled LCD. Call enable LCD. Again enable LCD, because now we have to send a pulse to the LCD at this point. Okay, so now which value we want to display now? We want to display A. Okay, so we can write it like this, display A. Okay, so if we want to send some data, to LCD, what should we do now? So we should write like this, clear RS, clear RS, clear RW, clear RW, and then move P2% hash image value in percent. Okay, so now we can also send the characters A. Character A. Actually, it will send the ASCII value of A. So this will send, if you use character A, this will send the ASCII value of A. ASCII value of A. And this is equivalent to, and the value of A is, so we can write like this, move P2 hash 65, and 65 is the ASCII value of A. And then we call enable LCD, and you can perform data operation to display other characters. You can also display then followed by, you can display V, then you can display D, and you can follow the same steps. ठीक है बेटा? Okay, so now I'm leaving